Good morning. In this lecture, we shall discuss user-defined functions and parameter passing techniques. So, these are the contents. So, we shall first discuss what is meant by actual and formal parameters, the categories of the functions based on number of the arguments and return type. And let us see the parameter passing mechanisms. So, this is very important concept and some of the program examples using functions. So, first we shall see what is meant by parameters. So, the parameters are nothing but what here the arguments which are passed to the functions to do specific task. So, there are two types of the parameters we have. So, one is actual parameter and second one is what here formal parameters. So, let us consider this example and will differentiate what is actual parameter and where these actual parameters are used and what are these formal parameters. So, in which location or for what purpose these formal parameters are used. So, this is a program which performs the addition of two numbers using functions concept. So, here we have declared two numbers. So, number 1 is initialized to 25, number 2 is initialized to 47. So, after these two statements, so we are calling a function name, that is add, by passing these two parameters, that is number 1 and number 2 here. And whenever the function is called, whenever this particular function is called, the control will jump to the function body. So, this rectangle shows whatever the code which is present in rectangle, this is what here the body of add function. So, here the content of num is copied into x, the content of num2 is copied into y, and it performs addition of x plus y, right. So, that is the content of x is what here 25, the content of y is what here 47. So, the content of num1 is copied into x after call and num2 is copied into y here. So, once after performing the addition, the result is returned back to the function where it was called and the result will be stored in sum here. See, whatever the parameters which are used during function call are called as what here actual parameters or arguments, and whatever the parameters which are used in function body, so those are called as what here formal parameters. So, the parameters which are used during function call does not require its type. So, we have just mentioned the variable name. So, we have not mentioned what is the type of this variable num1 and what is the type of num2 this variable is. So, the actual parameters does not require what are its type. So, these parameters are used to call a function. The formal parameters need to be mentioned by its type. So, that is why x and y is represented by what here its data type, and these formal parameters are used in function body. So, these two parameters are used, two types of parameters are used in function implementation. So, the same difference whatever I have explained just now is listed in table here. Okay. So, next we shall see the different categories of the functions, right. So, we have classified the categories of the functions. So, we have classified the functions into 4 categories based upon what here the number of the arguments the function is taking and what is the type of the return value it is returning. So, in fact, it is depends upon the argument and the return value. We have classified the functions into what here 4 categories. So let us consider an example. This is a function body which performs the which finds the area of the square here. So this is the name of the function, and this function is accepting one parameter, and after performing the operation this function is returning the area of the square here, right? That's why we have mentioned the body of this function, the name of this function as a function name. We have specified a parameter, one parameter it is taking, and after performing operation it is returning integer value. So depends upon the return value the function parameter. So we have classified into what here, 4 categories of the function. So the first one is what here, a function with no arguments and no return value. So we can implement a function where the function does not take any arguments and it does not return any value. So even we can have a function with some of the arguments are accepted by the function body, but it does not return any value. This is second category. And we can also have a function with arguments and return value. So the function will be taking the arguments as well as it will be returning the values. And some functions will not take any arguments, but still those functions will return the values. Such a functions are called as what here, functions with no arguments and return values. So let us discuss in detail by taking some program examples. So here the program is written for performing addition of the two number, right? So here we are not passing any parameters to the function, and we are not returning any value from the function body, right? So this is a main function. So within main function we are calling a function sum here. So this particular statement is called as what here, function call, and this is we called as what here, function prototype. So we have mentioned this function as what here, it does not take any value. So void means what here, the function which does not return any value. So and we have mentioned within a bracket as a what here, void. So void means what here, this particular function does not take any parameter here. Okay, so that's why we are calling a function just by what here, empty arguments here. Okay, whenever this statement is called, whenever this statement is executed, it will call the function. So the control will jump to the function body. So this is a function body, and whatever the statements which are present in this function body will be executed step by step. So here we have declared two variables to hold two numbers, and this variable will hold a result. So we will ask the user to enter two numbers. So whenever the user enters the first number as a 7, second number as a 3, so the 7 will be stored in n1, 3 will be stored in n2. So the content of n1 is added to what here, n2, the result will be stored in answer. So what we are doing, we are calling a function printf to display the content of answer, means the 10 result will be displayed on the screen. See, one thing you can observe is neither this function is taking, neither this function is taking any parameters, nor it is returning any value to the main program here. It does not return any value to the main program here. So this is what here, one category of the function. So even we can implement a function with arguments and no return value. So here we have declared the function as a what here, the function name sum, and it is taking two parameters and it does not return any value. So it does not return any value, means the result will be displayed in a function body itself. So since it is taking two parameters, we are passing two parameters, so that's why we are declaring two variables n1 and n2, and we'll ask the user to enter the two numbers. So whenever the user enters the number 7, that is stored in n1, number 3, that is stored in what here, n2 here, and we are calling a function by passing these two parameters. So whenever this function is called, the control will jump to the function body. So n1 is copied into x, n2 is copied into y. So the content of x becomes what here, 7, the content of y becomes what here, 3. So the content of x is added to what here, 3, the result will be stored in ans. So we are using a printf statement to display the content of answer here. So the result 10 will be displayed on the screen. So here what happening, the function is called by passing the parameters here. Hence the function is what here, taking some parameter, but after performing all the operation, the function does not return any value back to the main program here. So this type of function or this type of implementation is called as what here, function with arguments and no return value. So let us see third category of the function. So where the function will take some arguments and will also return some value. So we have declared the function with two arguments, that is x and y, and it returns the value of type what here, integer. So that's why the return type is declared as what here, int here. So first we will ask the user, two variables are declared and hence it returns some value. So to store the return result, we are declaring what here, this particular variable. So first we ask the user to enter two values. So whenever the user enters the value 7, the 7 will be stored in n1, 3 will be stored in n2. So we are calling a function by passing these two parameters. Whenever this function is called, the control will jump to what here, function body. So the content of n1 is stored in x, the content of n2 is stored in y. So the content of x is what here, 7 after copying, and the content of y is what here, 3. So x and y is added and it will return the result back to what here, function body. So means whatever the result which is 10 is returned back to what here, function call here. So the result of this function call is what here, 10. So the 10 is stored in where, ans. So next what we are doing, we are using printf statement in main function to display the value of ans. Hence this particular statement will display the result as what here, 10. So here you can see two parameters we are passing from the calling function to the called function. And in a called function, what is happening here, addition of two number is performed and the result is returned back to the main program. So this particular implementation is called as what here, a function with arguments and return value. And the last category is what here, the function with no arguments but return value, right? See, we have declared a function since we are not passing any parameters here, so that we have declared it as what here, void, and this function will return what here, the result of type what here, integer. So we are calling a function without any arguments. The control will jump to function body. So in a function body we have declared two local variables to store two numbers. First we will ask the user to enter two numbers. Whenever the user enters 7, the 7 is stored in n1, the 3 will be stored in n2. So content of n1 is added to what here, n2, right? So the result is returned back to what here, this function call. So the 10 will be stored in ans variable and we are displaying the content of ans. See, if you look at the function definition statement, so that is function name. See, here we are not taking any formal parameters here. Since we are not receiving any parameters from the calling function, So no need to mention here parameters here, right? So this is what here the function definition with no parameters, but it return a value back to the what here calling function. So these are what here different category of the functions which are categorized depends upon the arguments and return value, right? So it is left to the developer what category he is going to use for design and implementation of the particular program, and also it depends upon what here the requirement of the program implementation. So let us see the next concept, that is parameter passing mechanism. Okay, so before we get it into the parameter passing mechanism, let us first understand in detail how the variable is represented in a memory. Okay, so let us consider these three examples of variable declaration. So the moment when these statements are executed, a memory locations will be created in this manner. So every variable will be having what here the memory location. Every memory location will be having what here the address. So the 1000 is what here the address of the memory location, that is age. So 1002 is what here the address of the variable what here salary, and similarly 1004 is what here address of the variable DEPT here. Okay, so suppose if I want to access the content of this age variable. Okay, so suppose if I want to access this particular value, so there are two ways to access the content of that is age here. So one by using the name of the variable, and another one is what here by using the address here. Similarly, if I want to access the content of this DEPT variable, the content of DEPT variable is what here CSE. Suppose if I want to access this particular value, so how I can do this? Either I can use what here the name of the variable, or I can use the address of the variable. So what is the content of this address? CSC. What is the content of this variable? CSC. So you can use either name of the variable or memory address of the variable. Okay, see, in a functions whenever we are passing a parameters, so a question which may arise is whether can I pass the values directly to the function body or address. Okay, so these two are what here possibilities. Either we can pass the values directly to the function body, or also we can pass the addresses of the variable to the function body, right? So that particular concept is called as what here parameter passing mechanism here. Okay, so the parameter passing mechanism is used to send inputs or values from a calling function to a calling function, that is main, to a user defined function to do some specific task, is called as what here parameter passing mechanism. Okay, so we have two choices here. As I said already, either I can pass a values or I can pass a address, right? So passing the values is one of the mechanism, and passing the address is what here another mechanism, right? So there is a difference between passing the values to the called function and passing the address to the called function. So let us see in detail what difference will happen when we pass the values to the function body and when we pass the address to the function body. Okay, so let us take an example here, same program as I said already. So here two variables are declared, n1 and n2, and these two memory locations are created. The 1000 is what here the address of n1, 1002 is what here address of n2. Okay, whenever the user is asked to enter the two numbers, so the first number when he enters 10, the 10 will be stored in n1. The 20 suppose when he enters 20, 20 will be stored in n2 here. Okay, so what we are doing in this particular example, we are representing variables here. we are calling this function by passing what here? Variables. Okay, so what is n1? n1 is nothing but 10. What is n2? n1 is nothing but what here? 20. Means we are passing values to the function body here. Okay, similarly we can also pass the address. Instead of passing these values n1 and n2, we can also pass what here? 1000 and 1002. What is 1000? 1000 is the address of n1. What is the content of 1000? 10. What is the content of 1002? 20. So we can access the values 10 and 20 by using what here? The addresses of the memory location also. So we can also pass the addresses to the function body. Okay, so let us see in detail what is called by the function which takes the values and the function which take the addresses. So depends upon that we have classified into what here? Two types of the parameter passing mechanisms. So one is what here? Call by value. Okay, so call by value means what here? Whenever we pass the values to the function body, that particular concept is called as what here? Call by value. Okay, so here same program. So we want to perform the addition of we want to increment the content of two variables, right? See, this is a main program. We have declared two variables x and y. So the x is initialized with what here? 7. Y is initialized to what here? 3. So whenever these two variables are created, two memory locations are created here. So x, so this is content of memory location. This is what here? The address. Y, this is what here? Content, and this is what here? Address. Okay. So first what we do? We display the content of x and y. Okay, so what is the content of x and y? 7 and what is the content of x and y? 7 and 3. So next what we do? We call the function, the name is what here? Test, and it does not return any values. See, you look at the prototype of the function, it does not return any value, but it takes two parameters here. So that's why we are passing two parameters x and y here. So whenever this statement is encountered, the control will jump to what here? Function body. Okay, so what will happen? The content of x is copied into, say, x. What is the content of x here? That is 7. The content of y is what here? 7 is copied to this particular variable here. 3 is copied into this particular variable. So what we are doing? We are incrementing x by 1 here. So x becomes how much here? 8, and we are incrementing y by what here? 1. So y becomes what here? 8 here, right? And we are displaying the content of x and y. So the content of x and y is what here? That is 8 and 7. Okay, so once after executing all these statements, the control will again go back, right? The control will again go back to the point where it was called. So it will go back to this particular line. So next it will execute these lines here. So what we are doing? Again we are displaying what here? We are calling a printf function to display the content of actual parameter. So what is the content of actual parameter? X and y. So the content of x is as it is what here? 7. The content of y is how much here? 3 here. See, one thing you can observe is, see, we have changed the content of x and y in function body. Okay, after change, what is the content of x? 8. What is the content of y? 4. But this is not reflected to the actual parameters here. So why? Because another set of the copy will be created here. So what happens here? The content of x means, okay, another copy. So already 7 and 3 is present in these two variables. So whenever it is copied now, here another copy is created here. Okay, so these two operations are these two operations are performed with these two values, not these two values here. So that's why the original value of x and y is how much here? 7 and 3. The modified values of x and y, which is only belonging to this function definition, is what here? 8 and 4. So this is we call it as what here? Call by value and call by reference. So you keep in mind, in call by value, what happens? The actual parameters will not be modified, right? So due to modification of formal parameters. So let us discuss the same function, same concept by using what here? Call by reference. So what we do, in this case we will pass the address of everything is same here. See, x is initialized to 7, y is initialized to 3. Okay, so first we are displaying the content of x and y. So what is the content of x and y? 7 and 3 before calling function. So we are calling function by using what here? The address. So whenever we call this function, the control will jump to the function body, right? So here what we are doing, we are passing the address of x. So what is the address of x? Address of x is this value. So this is what here? Address of x. This is what here? Address of y, right? So star x indicates what here? The value at this address. So what is the value of at this address? 7. So the 7 is copied into x. What is the address at value? What is the value at this address? That is 3. So the 3 is represented by what here? Y. See, here another copy is not done here. The values another copy is not done. Instead, the content of the address is accessed and those contents are modified. So star x means what here? Value at address. Value at address is how much here? 7. 7 plus plus means what here? This becomes 8. Star y means what here? Value at address. What is the value at this address? 3. So that is modified. This became how much here? 4. So after that what we are doing? We are displaying the content of x and y. The content of x and y is what here? 8 and 4. So after execution of all these statements, the control will go back to the point where it was called, and here we are again displaying the content of x and y. So what is the content of x and y? 8 and 4 here. So here what happened, instead of creating another copy of x and y, here the content of address is accessed. Okay, these two statements have operated on the memory location content itself. Hence, everywhere it is same content, right? So let us see the difference between call by value and call by reference. So in call by value, in this method, the values will be passed from the actual to formal parameters. So in this case, instead of passing the values, we will pass what here? Address of the actual parameters. So that's why we have mentioned ampersand x ampersand y here. So ampersand x means what here? Address of x. Ampersand y means what here? Address of y. So the changes made to the formal parameters will not affect to the actual parameters. See, whatever the changes which are made, here, so these changes doesn't change to the content of the actual parameter. So but in case of call by reference, whatever the changes which are happened here, no, all those changes are reflected to the actual parameters. So capable to return only one value back to the call function in case of call by value. So this is capable of returning multiple values. The program execution is slower in case of the call by say value. So call by reference, the program execution is faster in case of call by value, because in call by reference we will operate on the address. In case of call by value, we operate on the values. So this is faster, this is slower here. So pointer knowledge is not required here, but pointers are required in case of implementing a call by reference here. Okay, so star indicates what here? Pointer variable. See here we have declared a variable without any star. So these are what here normal variables. So these are what here pointer variables. Thank you. So in next section we shall discuss some of the program examples using functions with a parameter passing techniques, and we'll discuss the definition of the recursive function and some program implementation using recursive function. Thank you.